Alright, for today's lesson, we are going to learn how to balance a chemical equation. What is meant by the term chemical equation? A chemical equation is a symbolic representation of a chemical reaction in form of symbols and formulae, where the reactant entities are given on the left-hand side and the product entities are given on the right-hand side. In this case, reactants are the starting material of the reaction and the products are the end results of the reaction. Abbreviations of element names are used to facilitate the equations. Abbreviations can be found in the periodic table of the elements. Why is it necessary to balance a chemical equation? It is important to balance a chemical equation in order to follow the law of conservation of mass. In simplified terms, the law states that there must be an equal number of atoms of each element in the reactants as in the products. Let's talk about coefficients and subscripts. When approaching a chemical equation, it is important that you understand the difference between coefficients and subscripts. The coefficient is placed in front of a molecule or a compound, while a subscript follows certain atom as shown in the picture. In a molecule, the coefficient denotes the amount of the molecule present. The subscript of an atom indicates the amount of the atom in the molecule. Adding a coefficient in front of a molecule multiplies all the atoms within the molecule by the number of the coefficient. If an atom has a subscript, the coefficient and the subscript multiply to yield the total amount of the atom in the molecule. Note that the coefficient is the part that can be changed and added when balancing the chemical equation. Changing the coefficient changes the total number of the molecule. The subscript, however, can't be changed because altering the subscript would change the molecule itself. We are going to balance the equation between ammonia gas and copper 2 oxide. And the following are the simple steps we are going to take as we are balancing the chemical equation. 1. Create a chart of reactant and product side of the equation. 2. Count the number of atoms of each element on both sides of the equation. Lastly, fill in the chart with appropriate atom counts. Therefore, we are going to draw a chart on the reactant side and the product side. Taking the next step, here we are going to fill in the atoms of the reactant side and their number, and the atoms on the product side and their number. We are going to start with the reactant side. We have one atom of nitrogen. Then hydrogen, we have 3 atoms of hydrogen. And copper, we have only 1 atom of copper and 1 atom of oxygen. What about on the product side? We have 2 atoms of nitrogen and 2 atoms of hydrogen. We have 1 atom of copper and 1 atom of oxygen. Back to our statement. When we are balancing a chemical equation, we balance atom per atom. On the reactant side, we have 1 atom of nitrogen. And on the product side, we have 2 atoms of nitrogen. Therefore, we write a 2 on this molecule to make the nitrogen on this molecule to be 2. But the 2 multiplies the whole molecule. implying that hydrogen now becomes 6. We have 6 atoms of hydrogen. What about on the product side? How many hydrogens are there? We have 2 hydrogens, but we have to make them to be 6 by multiplying a 3 on the 2 hydrogens which are there. So we write a coefficient of 3 on the water molecule. But the 3 on the water molecule implies that we have 3 oxygen atoms on the product side. Therefore, we have to make the oxygen atoms on the reactant side to be 3 by multiplying by a 3 here. Therefore, we write a 3 on the copper 2 oxide. The coefficient 3 on the copper 2 oxide implies that we have 3 copper atoms on the reactant side. Therefore, we have to make the copper on the product side to be 3 by multiplying a 3 with the atom which was there before. And finally, we obtain a purely balanced equation. Of course, your friend needs this. Share this video to your friend. Follow this account. Don't forget to visit my YouTube channel. This is Sulfur 16, the chemist.